Hello everyone, my name is David, and today I will show you an amazing mathematical trick. The trick is called Diffie-Hellman key exchange. It was published back in 1976 by two mathematicians, and today it's used in informational services where security is needed. Let's imagine a situation where two people who have never met before, let's call them Alice and Bob, are trying to exchange a number over a phone. But there's Eve spying on them and listening to every word they say. So how will Alice and Bob exchange a number without Eve knowing what that number is? Now, this is where Diffie-Hellman comes into play. They start off by both imagining a random number so that Eve won't know what numbers they imagined. Next, they somehow exchange those numbers. Obviously, they won't tell them to each other because Eve will also hear them. They need to disguise the numbers, and they do that by using something called one-way function. The core feature of a one-way function is that it is like a lock. It's simple or cheap to compute in one direction, but very hard or expensive in the other. I have here an example of that kind of function. 3 to the power of x mod 17 equals y. Now, this mod operator, as we heard on the opening ceremony, is similar to division, except it returns remainder of division. Let's say you have 7 apples, here, 7 apples, and you need to give them to 2 friends. You give each 3, and you are left with 1. So 7 mod 2 equals 1. Easy. Now you can see that it's relatively easy to take 3, raise it to power of x, and calculate modulus to get y. But it's very hard, given y, to calculate x. So Alice and Bob both imagined a random number. Let's say Alice chose 6. She plugs that in, and she gets 15. She then sends this result, her public key, to Bob, and Eve also hears it. Now, Bob takes, for example, 7. He plugs that in, and he gets 11. He then shares this result, his public key, with Alice. Notice that Eve now has their public keys, but not their secret keys. Not even Alice can know Bob's secret key, nor can Bob Alice's. And now for the heart of the trick. Alice takes Bob's public key, raises it to her secret key, and calculates modulus to get 8. Bob does the same. He takes Alice's public key, raises it to his secret key, and calculates modulus to get 8. And that's it. They will both know that their shared key is 8, but Eve won't be able to figure that out because she doesn't have their secret key. She has only their public keys. The problem of cracking this trick is called discrete logarithm problem, and with big enough numbers, this should take Eve a long, long time. Thank you.
Thank you, David.